Okay, so today, thank you for coming. We're going to talk about performance troubleshooting. It's not going to be specifically about Alfresco, but it's going to be a more generic approach to performance troubleshooting and a workflow that you can follow so that you can find easily your issues. So the agenda of the talk is like this. There will be a short introduction. Then I'm going to state what objectives I want to address in this talk. Then we're going to define what I would call the system model, and then define all the components that you have to work with. Then we'll talk about load characterization, meaning what load we're going to apply on such a system. And then we're going to talk about the core of the talk, which would be measuring, monitoring, profiling, and what you can do to find out what the problem is. And then we'll have a short Q&A session at the end, provided we have the time. So, short introduction about myself. I'm a solution engineer at Alfresco for about 3 years now. I've been mainly involved in pre-sales and consulting. I'm based in Paris, France, not Paris, Texas. My Twitter handle is @Romain Guinot, so feel free to tweet me to say how great that presentation was. My email is first name, last name, alfresco.com. Since that presentation is going to be on the web, I don't want to be spammed. And just a short survey. Who here has already had to diagnose the performance problem? Raise your hand if you did. All right, so that may be 1/3 of the room. Okay, that's interesting. And was it easy, hard? Raise your hand if it was easy. Okay, so that'd be interesting. So I think there's some people in the back. Can you see the screen in the back? That's fine. Okay, cool. So that should be interesting. So what the deal with this presentation is going to be having you have a better understanding of the system as a whole instead of just individual components. That will probably lead you to have better focus and better tool choice for a specific problem. And that will result hopefully in less frustration and a decreased time to problem identification. So let's start by defining what the system model is. The most basic definition that we can have is this one, I think. You just have like client activities, create a demand for system resources that you have predefined, and that results in response times that are either within or exceeding the tolerances that you want to have. So I'm just going to take this architecture as an example. I'm not going into detail about this because Gab is going to talk about that later in his presentation, but I just want to take that example to say that an architecture can be quite complex. You would have some client tier, Alfresco share, maybe multiple Alfresco shares, some load balancing, some content tiers, maybe multiple content tiers, some load balancing again to go to the index tier, and all that stuff goes to the DB for the database, and maybe NFS for storage or something else. So just give you an idea that this can get quite complex. And if you don't have the right tool or the right method to find the performance problem, and you just like go ahead and look at the code, then you'd be just like a chicken with a head cut off, you know. So that's not what you want to do. If we look at this from a physical point of view, of course, you would have maybe multiple servers that will host the tiers, the client tiers, some load balancing hitting the web tiers, maybe some load balancing also for the content tiers, multiple physical boxes, multiple index boxes with all sorts of components between them. Then you would have some JDBC going to the DB, some file protocol for the storage, maybe NFS, maybe CIFS, maybe SATA or whatever, or maybe you're using a SAN. So there is lots of different components that you would have to use. You have the disk drives, maybe there's an SSD drive, SATA drive, RAID drive, whatever. Some different types of memory in terms of amount, in terms of type, of bandwidth. That's something that people usually forget about the bandwidth. The CPUs, as we all know, in the last 5 years, there's been lots of improvements in terms of technology, in cores and caches, L1 cache, L2 cache, L3 cache, all that stuff that's share, non-share. And there's some very interesting things that we can find out about this. Of course, you have between the different machines that we mentioned some network bandwidth, some latency that is involved that we have to monitor too. And then, of course, you may have some additional components such as a RAID controller, dedicated hardware, load balancers, all that stuff. And if you look, presentation looks a bit, it's fine, okay. So regarding the software, you have the OS, the JVM, the applications, all that's going on with the different bits of software. So once you look at this from a different point of view, you need to really have a proper methodology to find out what the problem is going to be. So the first thing we need to look at is that the hardware that you're going to use for your project is probably going to be a finite set of capacities. We're going to give you a given infrastructure, and that's it. That's you have to work with, and you have to recognize that this hardware has limitations. It's not going to be infinitely scalable. It's basically static resources, and it has finite capacities in terms of throughput, in terms of capacity. So whether it's the disk, whether it's the memory, whether it's anything else, if you're putting too much demand on it, it's creating queues and serialization, and it's something that you have to monitor and work with. Basically, maybe you want to upgrade it if you find out that this component is going to be the problem. Maybe the solution would be, can I upgrade it or can I make less use of it? But you don't want to upgrade a component that you're not using. E.g., you're telling your boss, oh, we need more CPUs, and actually you're not using at all the CPU. That's going to be useless, and then you're going to be blamed for buying some new hardware. So once we've defined basically that, if I'm not making any sense because I'm based in France, just raise your hands and just say, I don't understand. But if it's a more general question, you can just wait for the end. There'll be a Q&A session. So now that we have defined all this system, basically, we need to define what load we're going to apply to that system. So the most basic things to define is that what type of testing do we want to run? Is it a load test, meaning do I want to cope with a certain load that's anticipated or predefined with the business users? Is it a stress test, meaning I want to put as much load as I can on the system and see if I still have data integrity, or does the system crash, or does the system just get slower, and just prepare for unexpected load? Or the third type of testing that we could have is endurance testing, meaning I'm going to have a test for like a week and see does the response time degrade over time, does the throughput stay the same over 1 week, because obviously if it's only working for 1 hour, that's not very useful. So once you've chosen the load test that you want to run, you have to define a test plan, obviously, and the test plan, you want it to be as realistic as possible. So you want to have maybe some variable or random, or sometimes called Gaussian sync times, so that it makes sense that people are not using the system repeatedly, and just they have some delay between the various actions. You want to have some different maybe user groups, because some people will not do maybe the same thing in the applications, and if you're only testing one scenario, that may not be realistic for your application. So you want to maybe parameterize to have some different variables in there and all that stuff. Something that is important to do also the ramp up, because you don't want to launch like 100 users immediately at T0. That's not really realistic, because people are going to come in, and gradually log into the system and do some things. So obviously, you need to have a proper ramp up and ramp down. As we said before, it's important to have a realistic test duration, because if you're only testing for 15 minutes, well, that's fine for acceptance testing or just unit testing, but that's not going to represent something that is real over maybe a business day or something. Something that's important to do too is basically watch out for how do you sequence your action and pauses. If some of you have already used JMeter, have someone raise your hand if you used JMeter already? All right, there's something you have to watch out for in JMeter is what they call the timers. You need to attach your timers to what they call test actions, because if you don't do that, and if you, for example, you have like a sample that does, let's say, does that request, and then you put the pause, and then you put the request and the pause and the request, it's possible that it would do request, pause, and that's not realistic. So if you're absolutely sure that the pause is between the requests, you have to attach a timer to a test action. It's a bit clunky, but that's the way it works usually, depending on the version of JMeter that you are using. So be sure to watch out for that. whichever tool you are using for load injecting, you need to get some stats. And I'm sorry that the presentation is not really rendering, but the average, just getting the average response time is not enough for me. You need to get some stats. You need to get some variance. You need to get some stability, variance to mean. All the statistics are really required to basically get an understanding of the results that you are having. Because just the average is really not enough, as we'll see later. So basically, once we've defined our test plan, what will basically happen in the system is this. You have end users that is going to make application requests. The application itself is going to translate those requests into basically sets of local instructions and calls to external systems. Maybe it's the database, maybe it's the storage, or maybe it's a completely custom separate application. This will be handled in the JVM. The JVM will be basically doing the translation between application instructions that we've just talked about and OS machine instructions. Also has to do memory management, as we'll see later. Basically, underneath all that, the OS will provide core allocation, CPU core allocation, thread scheduling, and memory allocation, provisioning, and basically all that stuff. And maybe access to local hardware. So once we've said all that, I think what we need is really navigation. What do I do when I found a performance problem with regards to all that? So we need, when you consider all the architecture that we've mentioned, the hardware, the OS, the JVM, the applications, and the different types of users that might use that system, what I think we need is a performance workflow that will help you to shift from just looking at the code. That's not going to help you, and focusing maybe on the wrong component. So what you need to do is understand the system as a whole, and then find out, by following a simple workflow that we are going to talk about just now, which the problem is. So we're getting to the core of the talk. Once we've defined all of this, is there any questions so far? Or okay. So we're going to talk about what you can measure, monitor, and profile to find out what the performance problem is going to be. So I would say that this is the basic decision tree that I use, either in consulting engagements or performance troubleshooting. Basically, you're going to start with analyzing the CPU usage and differentiate between system CPU and user time CPU. System CPU is basically happening in the kernel. User time is in process CPU, and depending on that, you're going to find out, maybe I need to go look at the OS kernel interaction because I have maybe some network or I/O latency, too much context switching, too much locking. Every step of this workflow we will be detailing in the following slides. So I'm just going a brief overview. Then you're going to look at maybe why my CPU are not used. So you would be doing thread dumps, or maybe you have a problem with the JVM configuration, or maybe a memory leak, or some algorithm that is not really useful. So we're going to be detailing all of these different steps just now. So the first thing, as we said, the first thing you want to do is look at the CPU usage. So is it above 10% or not? So what I usually use as a tool to determine with that is VMstat. VMstat is, who has used VMstat? Raise your hand if you did. One. Well, 1.5. Okay, that's interesting. VMstat is basically giving you stats for the global amount of cores. So whichever amount of cores you have is going to be summarizing everything. MPstat will give you the stats, basically about the same stats per core. Just mentioning that the tools I'm going to mention are usually Linux or Solaris. This is the OS that we have to face basically on a daily basis. But there are probably equivalent tools on Windows. I'm just not going to mention them. Likely. So this is a sample output from VMstat. Just pretty easy to find out, to figure out. The first section is the processors, tells you about processor usage. So you have the R column that says how many processors are running at the same time. The B column is telling you block processes. With regard to the R column, if you want to look at maybe if you have a number of R that is larger than twice the number of cores that you have, it's probably CPU starvation. So this is a case that we are going to look afterwards. You can work with that by either reducing the CPU usage or adding more cores, obviously. SO is the swap columns. This is something that you want to be particularly watching out for, because by default, if you're working on a Red Hat system, there will be a value. There's a kernel parameter that's called vm.swappiness, and that tells you the kernel about which amount of RAM is full before he starts swapping stuff. And this is very important because there's a severe performance cost if the system starts swapping. So what you want to do usually is set that to 5, for example, so that it doesn't swap anything before 95% usage. And this is something that people usually don't know or forget, but it's very, very important. And I'm not exactly sure what the default is on Windows, but you still have the same swap idea. And if you are, for example, using a VM that's on the SAN, and that the SAN, you're swapping on the SAN, it's going to be hundreds or 1,000 times slower than if you are using your RAM. So that's something that you really want to watch out for. The second column, the next column is the, sorry, we talked about, okay, the swap, we talked about it. The I/O, we'll talk about it later. The system column, there is the IN is interrupts, so that's basically stuff in the kernel. CS is context switching, and that's very interesting because that means that if you have a very high context switching, that means that your threads are not using the time quantum. And for that reason, maybe there's too much locking, threads are jumping from core to core, there's too much network going on, too much I/O going on. US is user time, this is what we just talked about a bit earlier. Sys is kernel, ID is idle, so basically doing nothing. WA is waiting on I/O, and ST is stolen from Xen if it's supported. That's something that was added about recently. If you are using Xen, for example, as a hypervisor, you can find out how much time of that actual physical CPU is spent in another VM than yours. Doesn't support it on every type of VM, but it's still interesting if you want to find out, if something was misconfigured. So in that case, if you have like a high percentage of system usage or a system usage that's about the same as the user usage, then you want to do, and you have obviously response time that's above accepted response times, otherwise you have nothing to do. Then you want to look at OS interaction. Is it I/O? Then you would maybe use I/O stat, for example, to find out what's going on. Then you would have to be maybe using netstat or nextstat to find out about network performance. The last line is mangled, but it's talk about all the kernel profiling tools such as dtrace or strace or oprofile, all the tools that are going to help you find out what's going on in the kernel and why is there so many system usage, for example. So we've talked about this first section. The next section we're going to talk about is the case where you have actually little CPU usage, which is what I call no dominator. So if it's a no, then what you want to do is do some thread profiling. That is the case where you have low user time, low system time, and still response time that are worse than you would want them to be. So in that case, what you want to find out is what's preventing your threads from consuming more CPU. E.g., you have blocked threads, synchronized threads, locks, high I/O, high net latency, waiting on external resources such as the database, for example. The tools I'm going to use for that are TDA. Who's used TDA before? One. Okay, yeah, but it's from Alfresco, it doesn't count. Yeah. TDA, so this is a pretty cool tool to analyze thread dumps. Or you can also use Yourkit in a thread profiling mode. I think it's even better, depending on the context. So we're going to work with a short example from a customer for that use case. What they had basically is a custom front end, Alfresco server in the back end, and complaining about poor user performance. So what we did is that we profiled the back end. Nothing much was happening. So we decided to provide the front end. And basically, this is what we saw. and clearly this is not good because the red is all blocked. The red bits are blocked threads. So every time you just looked at the threads, it was like waiting for a lock, and there was actually massive synchronization overhead in that front end. And what was even worse is that they had changed our own code by keeping the org Alfresco prefix. So when we looked at stuff, it was very strange, and we found out it was their custom code doing all sorts of wrong things. So basically, when you have that problem, you just click on the red bit, and it will tell you what is blocked for, what it is blocked for, what it is waiting, and the exact line of code where the problem is happening. So that's just very easy to do. And obviously, as you can see on the back end, nothing much was happening because the yellow bits are waiting. So in that, if you see something like that, that is actually Yourkit profile in thread profiling. And if you see something like that, the possible causes are maybe in that case was because the server was so massively, the front end was so massively synchronized that basically nothing was getting through. Everybody was waiting for a lock, and there's just one thread going through at a time. So obviously the server had not much to do. And the second problem that they had is that there were some DB queries that was pretty slow. So the server was also waiting quite a bit for the database. Obviously, in that case, the contention, was reducing the amount of requests that were going through. So this is something we're going to talk about also, the database profiling. I think there are some pretty cool tools that you can use that I'm going to talk about right now. The usual issues that you have when you go on site and you have very little time and you need to find out the problem with the DB is that maybe you don't have the proper DB access, or the DBA doesn't want to give you something, or doesn't want to give you access to the DB. So and the DB, or maybe the other problem is going to be that the DBA is going to tell you, well, from the DB point of view, everything's fine. So I've got nothing to do. So it's interesting, I think, to have profiling from the application server, because then you can find out the response time that you are actually seeing from an application server point of view. So the tools that I'm using for that are P6Py and Percona Toolkit. Anyone who's used that? Raise your hand if you did. One guy. Okay, interesting. So you can find it all about on the wiki. I've written a page on the Alfresco wiki that details everything that you need to find out and need to know how to set it up. The cool thing about this stuff is that it's basically DBA or DB independent. You can use it with pretty much any DBs that we support. You get a point of view from the application server, and so that's pretty good. You can compare it with the DB stats if they're available. It's pretty lightweight. There's basically no dependencies. It's just a jar, as we'll see. You can do the analysis and data parsing on another machine. So you basically only need to collect the logs just on the server and then take the logs and analyze them locally. It uses system the current time millis, so it's millisecond resolution. It's statistically relevant, I would say, especially if you have the network in between, because then you most likely gonna have response times over 1 millisecond. If you are using a database locally and you have nanoseconds, then you might have some less relevant results, but it's still statistically you will be relevant. As I said, it's very simple to configure. Just put a file. This is a spy properties file. You can just drop in Tomcat shared classes. Mainly, you just configure the DB driver, log appender, and the output location, and that's just basically it. And in Alfresco Global, you would then use the P6Py driver instead of the actual driver that you are actually using. And it's pretty low overhead, but be aware that the log files can be large pretty fast. So you need to make sure that you have some file system space to accommodate for the amount of queries that you're going to log. As you can see in that example, basically I just took a log from a customer problem and ran it through the tool. And as you can see, I don't have the pointer thing in, but that's fine. There are several columns. There are the rank, basically, of the query, meaning they are ranked by impact, and the impact is basically the response time multiplied by the number of calls. So that gives you an idea of how much time you're spending on that type of query. So you get the response time overall for the whole test of that particular query in terms of percentage, in terms of number of calls, response time per call, AppDex is a statistical index that you can find out about, we can talk about later. Variance to mean, it gives you an idea of the stability of the response time of that query. And then item is pretty interesting because it will aggregate queries of the same type in the same category. So it doesn't matter if the values inside that query change, they will still be aggregated, and you can find out, that specific query, for example, in that case, number 1 is accounting for 37% of the time I'm spending in the DB. And if you want to do, if you need something to improve in your DB, it's much better to focus on the number 1 query than focusing on the query that has no impact whatsoever. So as you can see in this example, the 2 first queries are accounting for like maybe about 50% of the time, and it's all about locking. So that's something that is very interesting. And what we found, something I didn't mention is that this is the summary output, but you can find out more detailed statistics for one specific query. So if you want to say, okay, now I want more info on query number 1, then you would run run command, and that will give you, in addition to what we just seen, also a time bucket distribution. So you can really easily and visually find out where my queries in terms of response time are. So that for that query, you can see that most of the time it was in the 100 millisecond range, sometimes a bit faster, but that's about what you would get. And you would have also the statistics in terms of numbers. So you have the minimum, maximum, average, 95% time, standard deviation, median. As we said earlier, it's much better to have lots of statistics than just the average, because the average doesn't really mean something. And you'll have one example of that query. So if you know that query is problematic, you can just take that one, give it to the DBA, ask the DBA, give me the query plan. Is there a missing index or something? So that's very interesting, because as we said, with like 0 dependencies, just putting a jar, you have lots of stats from the application point of view. Whether it's Oracle, Postgres, MySQL, and whatever, it will work just either way. And it's very easy to set up, very fast. So you can just go and really pinpoint the problem. So in their case, it was because they were adding too much pessimistic locking in the custom code, and obviously that was creating too much of a drag on the application. So they reviewed the app, moved to optimistic locking because that was fitting with their use case, and the problem was gone. Just a note, make sure that, it's a general comment, but make sure that your DB stats are collected and up to date for the query plans, because that's usually a problem that we see. The DB stats are completely out of date, and the query plans are just bad because the DB cannot make the proper choice. What's cool about that tool, there is also other parser that you can use for that proper tool. So you can also parse TCP dump output and get some. If you are using MySQL, you can parse the MySQL wire protocol. It's pretty powerful, because then if you are using MySQL, you can compare the response time that you have on coming out of the DB and then on the application server. So you can find out very easily where's the network overhead between the two if you are using that DB. You can also parse the Postgres log, the MySQL general log, slow log, memcached, HTTP. So that's a pretty cool tool. I encourage you to look at it. Just a quick note about time resolution. There is about system current time release and system nano-time. There are JNI, so there are native calls. So basically, the precision for that implementation is completely dependent on the OS, and the JVM the JVM spec cannot guarantee anything about that. So that's very important to know. It's pretty good on Linux and Solaris. On old Windows, it's really bad. So it's like maybe 50 milliseconds precision. So that's not going to be very interesting. It may not be precise for one specific event, but in our case, we don't really care. But because we are looking at a very large body of queries, a very large body of events, and statistically, it will be relevant, even though one specific event may be out of focus. So we've talked about these 2 items. When I'm on time, I'm doing like 20 minutes. Okay, that should be fine. So we have 2 items left, the JVM and the application. So basically, if you are looking at the CPU, and the CPU usage is pretty high, I'm not talking about system CPU, but user time CPU is pretty high, you want to look at your GC logs. That is the first step that you want to look at. garbage collection logs. So just a big quick reminder, I think most of you should be probably familiar with this, but there are several generations in the JVM, one called young, one called tenure or old, depending on what you're looking at. The Eden is separated in two, with the young generation is separated in two, with the Eden and the survivor spaces. Basically, objects are starting out or allocated in the Eden, and then are moved to the survivor spaces a certain number of times, and then moved to the old generation. I'm not going to talk about this because we could talk about for an hour, but that's basically the very basic idea. And you have the permission which holds basically the classes, the code cache, and all that stuff. So the basic idea about GC logging is very low overhead to leave it in production. So I know that some people just don't want to leave it in production because they fear about the overhead, but you can really leave it on, no problem at all. It's a couple of percent maybe on top of your GC overhead. So if your GC overhead like 3%, then maybe you'll have like 3.1% overhead. So it's really something you can leave on. It gives you relatively small log files, and it yields very, very valuable information, as we can see later. So if you are intending to use it, please use xlog.gc instead of verbose GC, because log.gc will log to a file instead of the console, so the overhead will be even lower. So there's an example just below of the stat that you can use. Just a note, on Java 7 you can use rolling log files. So if you're worried about the size of the log or the number of log files, you can use that. There are a couple of flags that are not shown here, but you can use them just to find out, to determine if either the size of the log file that you want to reach, or the number of log files that you want to log into, or the maximum file size starting in Java 7. So if you have Chuck Norris skills, you can read GC logs by hand, and you have basically different types. And so the red bit would be the type of GC, the green bit would be the pause time for that particular GC, and the yellow will have the before GC in that generation. So it will tell you also after GC in that generation, and also as a reference the generation size. But if you are not Chuck Norris, there are some pretty cool tools that you can use to graph the behavior of GC in the JVM. And the tool that I like to use is HP JMeter. Who has used HP JMeter before? Okay, no one, so that's good. Interesting. So basically what you're going to be able to find out with the GC is that you'll be able to have some stats on the heap, percentage of time in GC, etc., etc. The most important would be heap usage after GC, as we'll see in some examples later. You could also graph the GC duration over time. Does my GC increase in time as the application is going through? Creation rate is basically the rate at which you are allocating objects. And you can find out if you are hitting, for example, hardware limits against the memory allocation. So that's something that you need to watch out for, and many other things that we'll look at maybe later. It's free. It's downloadable at this address. There's a comment down there that's a bit not really seen, but it says basically that in JDK 7, the GC log format for the decimal timestamps that we just mentioned, the green bit has changed from commas to dots. So if you want to use HP JMeter for JDK 7, you just have to previously fix your log by changing the commas to dots, either using sed or a graphical editor or whatever. But that's something you need to be aware of. What you can derive from the GC log is how much time am I spending in the GC with regards to my application. Is my heap sizing properly configured? Do I have a proper generation sizing? Do I have premature promotion, meaning some objects are going to the old generation, and if we had waited a bit longer, they would have died in the young generation, which is better because the cost of collection in the young generation is very small compared to the old generation. Tenoring thresholds, I think we are going to skip that because we are a bit short on time. Heap usage after GC, memory leak, creation rate, allocation rate, as we talked about with regards to the bandwidth of your hardware. So this is a small example of a heap that I've deliberately really, really small sized. I've just started Tomcat with 96 megabytes, and obviously he didn't like it, as you can see, because the purple bits are basically emergency GC, and the JVM is doing whatever it can to salvage whatever it can. As you can see in the little text box, we're spending like 75, maybe 80% of time in GC. So I just wanted to include that graph because I want you guys to be careful about calling out memory leak. Sometimes you just call out memory leak, and as we can see in this example, it wasn't memory leak, just that the JVM was not configured properly. So you want to watch out for the full GC to GC ratio, heap sizing with regards to the working set size, progress over time, object surviving too many connections compared to the usage. As you can see in that real example of a customer case, can anyone tell me what's going on there? Oh. Raise your hand if you want. Okay. No one has a guess. Well, as you can see, it's pretty interesting because the heap was growing until there was a massive problem. And the heap was massively full and doing lots of GCs. And at 3 a.m., GC was just like, oops, sorry, would free all the objects that we needed to free. So that's pretty cool. Does anyone know what's going on at 3 a.m. in Alfresco? By default. Sorry? Lucene backup job. Yeah. So that in that case, it's very interesting that the Lucene backup job managed to clear out all the problem. And in that case, that's very indicative of a memory leak, because instead of just having stabilizing, we're just going, as you can see here, as I indicated, that's 2 gigs for the XMX and new ratio 2. So that's basically 1.3 gigs for the old generation. So basically, we saturated the old generation for some hours, and then there was nothing we could do, and then it went back up. So what do you want to do if you want to investigate that memory leak? That's actually pretty easy. The general method would be to analyze the GC log as we've just done and suspect that there is a memory leak. The thing you want to look at is the generational count, meaning the objects, how many collections the objects that you're looking at have survived in. And that helps you identifying the leak candidates. Depending on the GC type, we're not going to talk about too much about this because there is not much time, but basically, e.g., it would be probably 15 for a CMS if you're using the CMS GC. You want to exclude all the legitimate classes that may stay very long in the JVM, for example, EH cache stuff or Lucene cache or whatever. And you can use JVisual VM for this information. It's very useful. You just plug it in. It's provided with the JDK, and it will tell you without a very high overhead the generation that your objects are staying in. And once you've identified some candidates, what you want to do is get some allocation track traces to find out where those objects are stayed in or allocated. You also want to get a heap dump after GC to make sure that you find out. And then once you have your heap dump and you have identified the objects that are leaking, what you want to identify is the path to the GC routes, meaning what's the chain of objects that those objects are allocated in. And the last comment says you can use Yourkit or JVisual VM. As you can see in that example, this is the heap dump from that memory leak we were talking about. The strange thing is that there were like 900 megabytes of exceptions retained in the JVM for some reason. And if you look at the merge path, which is basically allocation stack traces back to the GC routes, you can see that this is the class that was holding most of this stuff. So if you look at the code, so basically instead of just looking randomly at the code, we just took a couple of steps, and the tool just pinpoints the location of the leak. So basically, the only thing that you have to do is look at that class for some usage of a linked list and inspect that. And this is what we're going to do now. As you can see now, there's just a typo. There was a method that was saying decrement, and instead of decrementing, it was an add. But this is something there's no way you can find out if you don't have the proper tooling and the proper analysis and methodology, because there's just too much stuff going on to find out. So instead of so instead of going for an add, just put a remove instead of an add, and maybe use a double-ended queue instead of a linked list. Just pop the last item every time. This is actually a bug in our own code, so I'm not only blaming the customers, but it affected a rare scenario where you have absolutely no writes to the index, and you're basically searching against it all day long, massively. So that's a very rare use case, because usually people have at least some writes, and people adding documents, changing properties, whatever, at least once a day. And in that scenario, it didn't happen for a whole day and just had a leak. And as you can see, once we've changed that code, it now looks much better. It just stabilizes for like more than a day, and everything's fine. As you can see in the statistics, we're just spending 3% time in GC, which is reasonable. 3% is good, maybe up to 5%, that would be fine. So the last bit that we have to talk about. How am I doing on time? 8 minutes? Okay, I'm being short. Okay. So the last bit, I was actually faster than I expected. The last bit, sorry. Oh. Okay. Test. Okay. So we've talked about all of this point. The last bit we have to talk about is basically the case where you have high CPU usage and no detected problem in the JVM or the GC logs. And the last bit will be application, and that's probably because you have maybe algorithm issue or something. So this is the last bit. You have high usage CPU, low system CPU, no issue detected with the GC log or VM config. What you want to do in that case is execution profiling, basically CPU profiling, usually with a VM agent. I usually use Yourkit for that. You can use it for free for a certain amount of days. Be aware though that this profiling has a pretty high overhead, so you don't want to do it in production. You have to do it in a test environment. Since we have a bit of time left, there's a bonus topic. It's about VM flags. We sometimes see people going in with like 1,000 flags in your JVM, and it's completely useless because there are people at Oracle whose job it is to make those flags obsolete. So start with a really minimal amount of flags. Basically XMX, that's it, or that's stash server. Maybe select a GC, or maybe select some generation sizing if you know or what to expect. But every release is going to change things and tips, and set this out and set that out, So that's not a thing. That's not what you want to do. Out of curiosity, what you can do is that you can extract out all the VM flags that are available for a specific VM by running, for example, if you're using Linux or Solaris, you can run strings on libjvm.so, and you can find out all the flags that you have on a specific release of the JVM. If you have access to the JVM source code, you can look at globals.hpp. That's also another way to find out. And a cool thing that you can do when you have all the flags is you can basically run a loop and use jinfo. There's a tool that's provided by the JDK, and it can give you the value of a specific flag on a running JVM. So basically, if you have all the flags and you have the VM running, you can just get all the flags, and out of curiosity, you'll find out what are the default values for all the flags. And that's basically, there are about 760 flags in the latest JDK 6 release, about more than 800 in JDK 7. So obviously, I don't know all of them, but it's just interesting on a out of curiosity to find out mostly what has changed from release to release. Because if you find out, that one specific flag was turned off, maybe they're adding a new feature, or maybe some of the default flags are changing. So that's something that you can look out before upgrading your JVM. All right. Do we have any questions?
Was that JMeter that gave you the graphs of the
Yes, but that's HP JMeter, not Apache JMeter. Right? You can download it for free, and then you'll be fine. Yeah, HP JMeter is pretty good. Yeah. like it. Yes?
Yes, is there a tool that combines all of this one and give us a PSR or
No, I don't. Not really. There is. Well, you know, as we just mentioned, if I found the graph, you know, every case is a bit specific. So if you want to look at, you know, OS interaction, then it's going to be probably a tool dedicated for that, and it's not going to be a GUI tool that's going to do all of this in one. But, you know, maybe someday they will. For now, you just have to select out the best tool that for each bit, and also tools that you are comfortable with. You know, this is mostly examples. There are alternatives that will give you the same information here.
How about to monitor like whether we have enough database connections?
Sorry, I didn't understand.
If I want to know that Alfresco has enough database connection pool.
Oh yeah, okay. But that's something. If you have a too small connection pool, then you would be probably in the first example that we saw with too much. That one. If you maybe you would set the connection pool to 1, and like load test 50 users, you'd probably see something like that. You know, users trying to acquire a DB connection. So you want to do if you had slow response times. And because of the DB contention, you would have something like that. You would see in the stacks, if you click on the red, you know, acquire a DB connection. I don't know what the method is in DBCP, but that would be something like that. Yeah. Anyone else?
When you're talking about using the VM stat command,
Yes.
you mentioned something about determining high context switching.
Yes.
How do you determine if that's high?
Well, it depends on the number of CPUs that you have, because obviously, if the number of cores that you have, and depending on the OS, for example, if you're on Linux, there will be some default context switching going on. Some basic value that's not going to be very important, but maybe if you see, for example, 250,000, and you have 25 cores, then that's problematic. Yeah. It's not specific value. You have to basically understand, you know, the OS, the number of cores, and from experience diagnose, you know, that seems high. Maybe a couple thousand is usually regular for a Linux server, but then if you have maybe 10,000 per core, that's going to be too high. Yes? Okay.
Everything looks good in our I/O stats, but the performance was very slow, and it seemed like an I/O problem.
Mm-hmm.
And it was actually an under-resourced VM and the hypervisor moving VMs around. So in the VM world, which we're all in, one of the first places is just to check on the health of your VM.
Mm. Yeah. Now, I think I was talking with a VMware guy some time ago, and he mentioned that there was some tooling you can install on the actual VM that will get some health on the hypervisor. And I don't remember the name of the tool because it's mostly something that they keep internally for their consulting stuff. But there is something that would be great to have in the VM so that the VM would be aware that it's being under-resourced. Something that you can find out when we mentioned the VM stat output. If you have the ST column, that's basically the amount of time in the CPU that has been stolen from another VM. So it depends on the release that you have and the VM that you have. Sometimes it's not supported and it's just going to say 0 or whatever. But it's something that you can watch out for. Out of time? Okay. So if you have any more questions, feel free to come find me in the halls and we can discuss it. Otherwise, thank you for attending. Yeah.